Hello, 6th grade mathematicians. We are going to get started on Chapter 6, Lesson 1. We are going to be starting powers and exponents, which is basically going to be moving us into algebra. So you need to have your book. You need to have a pencil, and your book needs to be open to page 433. Again, what I do, you do. So make sure you are following along with me as we get started. So let's take a look at this first part. We are going to take a look at what vocabulary words we need to know, the most important pieces of what we need to know. We're going to be talking about powers and exponents. So a product of like factors can be written in exponential form using exponent and a base. A lot of words that we might not have heard of. A base is a number that is used as a factor. So for example, right here, this 10, that is your base. So write your base right there. And these are our factors. Well, we know that. Those are the numbers we're multiplying together. Okay, so we're multiplying 10 times 10. Those are factors. And then we have a base. So let's make sure that we underline this and we star that because that's a very important word. The exponent tells how many times the base is used as a factor. So take a look here. How many times are we multiplying 10 by? 1, 2. Therefore, that is your exponent, and that tells us that we are multiplying 10 2 times. We're not taking 10 times 2. No, we are taking 10 times 10. We're taking our base and multiplying it twice. All right, let's give an example of an exponent. Let's do 5 to the third power. So what is the exponent? The 3 is the exponent. Oops. There we go. Let's see. It says, write the definition of an exponent in your own words. Go ahead and hit pause. Write a definition of exponent in your own words, and then start the video back up. Okay, so you would have written your own definition of what an exponent is so that you can try to remember. All right, turn to the next page, 434. Write product as powers. Numbers are expressed using exponents called powers. Okay. Example, 100 is a power of 10 because it can be written as 10 times, or 10 to the second power. So 10 to the second power is the same as 10 times 10, which is the same as 100. Okay. Numbers like 100 are perfect squares because they are the squares of the whole number. So take a look at this one right down here, where we have 10 times 10 times 10, which equals 1,000. And so 10 to the third equals 1,000. Okay, so let's think about this. It says perfect cubes are numbers with 3 identical whole numbers with factors such as 4 times 4 times 4, which is 64. So the number 64 is a perfect cube. Okay. All right, let's take a look at some examples. We're going to take a look at number 2. So we're going to do 4 times 4 times 4 using exponent. If I took 4 times 4 times 4, my base, and I want you to write this down, my base right here is 4, but then I want you to tell me what my exponent is. How many times did I multiply 4? I multiplied 4 times 4 times 4. So my exponent, okay, my exponent is 3. So the factor blank is the base, which we said was 4. We found out that we are going to multiply that factor 3 times, so therefore our exponent is 3. And how do we write that as a exponential form? We write it as 4 times 4 times 4, which is 4 to the third power. Okay, 4 to the third power. Let's practice writing exponents here. So 7 times 7 times 7. First of all, our base is 7. And how many times did we multiply it? 1, 2, 3, 4. So 7 to the fourth power. All right, our base is obviously going to be 9. 9 times 9 times 9 times 9 times 9 times 9 times 9. We multiplied that 7 times, so it's 9 to the 7th power. Again, remember, it is not 9 times 7. It is taking that base and multiplying it by itself 7 times. Okay? All right, let's go to the next page. Write powers as product. To write the powers as products, determine the base and the exponent. The base of 10 to the second is 10 to the exponent is 2. To read powers, consider the exponent. The power 10 to the second is read as 10 squared, and 10 to the third is read as 10 cubed. Those are our only differences, because when we start talking about area and volume, you're going to need to know the difference between squared and cubed. Okay, so let's take a look at this. We're going to jump down here, and we're going to take a look at 3. So write 5 squared, or 5 to the power of 2, or 5 to the second power, as a product of the same factor, then find its value. So really, 5 squared, even though it's over here, I want you to do it too. 5 squared really equals 5 times 5. Okay, so 5 squared really equals, what's 5 times 5? 25. Therefore, we found the value and we wrote it as the same factor. So we did both. Okay, let's jump down here. Take a look. Can we do it with fractions? Yes, we can. Okay, so we're going to take 1/2 to the power of 3, or 1/2 cubed. So we're going to take 1/2 times 1/2 times 1/2. Okay, and when we take 1/2 times 1/2 times 1/2, we know we multiply the numerators, and then we multiply the denominators, which gives us 1/8. So therefore, 1/2 cubed is really, the value is 1/8. All right, let's do some practice together. Let's take a look at C. 10 to the 5th power really means we're going to write the product, each power as the product. So we're going to write 10 times 10 times 10 times 10 times 10. So we're going to actually write it 5 times. And when we take 10 times 10 times 10 times 10 times 10, we know we're going to get 1, and we're going to get 1, 2, 3, 4, 5 zeros. Whoops. 1, 2, 3, 4, 5 zeros. So 100,000. All right, so 2.1 to the 2nd power, which really means 2.1 times 2.1, or 2 1/10 times 2 1/10. And when you use your calculator, or when you actually multiply, you are going to get 4.41, or 4 41/100ths. And the last one, 1/4 to the 2nd power, 1/4 times 1/4. I'm going to multiply my numerators. I get 1. 4 times 4 is 16, so we get 1/16 is the value. All right, let's take a look really quickly over to this page, the next page, 436. It says, we're going to take a look up here. It says Michigan has more than 10 to the 4th inland lakes. Find the value of 10 to the 4th power. So that means we're taking 10 times 10 times 10 times 10. Our basic fact is 1. How many zeros do I have? 1, 2, 3, 4. 1, 2, 3, 4, which gives me 10,000. So my answer here would be, 10,000 lakes. Okay? All right, we are going to do these problems, and then you are going to be done and on your way. So write each product using an exponent. So 8 times 8 times 8, our base is 8. We multiplied the 8 3 times, so it's 8 to the 3rd, or 8 cubed. 1 times 1 times 1 times 1 times 1, it is 1 to the how many times? To the 5th. Okay? The next one says, write each power and then find the value. So 1/7 to the 3rd. So that means we're taking 1/7 times 1/7 times 1/7, which gives us 1 times 1 times 1 is 1. 7 times 7 is 49. 49 times 7 is 343 when you multiply them together. All right, 2 to the 5th power is 2 times 2 times 2 times 2 times 2. And when you multiply 2 times 2 times 2 times 2 times 2, you get 32. And number 5, 1.4 to the second power is 1.4 times 1.4, which gives you 1 96/100. Okay? Let's take a look at this one. It says the coal mines have shafts that can be used 7 3³ feet deep. How many feet deep is the Earth's crust on these shafts? So 7 to the third is written as 7 times 7 times 7. 7 times 7 is 49. 49 times 7 is 343, and we better label it with feet. Okay, there is your powers and exponents, and you are ready to go on with whatever assignment you have next. Good job, mathematicians.